Today we are doing the Asteroids project again, but this time we're doing it with kids. Myself, Ethan, and Leon will be each recording our own version of this video and editing it to our own preferences. I'm going to add in some links at the end so you can get their versions of the video and their understanding of block programming. We're going to start off by making a black screen with color 0, saturation 0, and brightness 0. I'm going to use the paint bucket tool to set the backdrop as black. And then on the side I'm going to make a new sprite for stars that I'm going to stamp all over the black backdrop. For the stars I'm going to use the paintbrush tool and I'm going to set the paint editor to bitmap mode. After that I need to update my colors so I can have white stars at color 0, saturation 0, and brightness 100 for the color of the stars. Then I'm going to zoom in real quick and draw a small plus on the middle of the screen to act as my star stamp. Now that the art is done for the star, it's time to add some code. First, when the green flag is clicked, we want this to repeat 10 times. After that, I'm pulling out operators for pick random because this is an important function of our script. The basic idea here is that we want some randomization for location of the stars all over the screen. I imported the PEM module so that I could stamp the shape of the star sprite all over the screen. Next, I'm dragging out a script for go to X location and Y location. To explain this more, we have a diagram. In Scratch, there's a special backdrop that you can use to help explain coordinates in terms of how sprites move around the screen. All the way at the bottom, there's a backdrop called XY grid. On this XY grid, you can see the size of the stage that these sprites have to move around on. I'm going to use a black pen to highlight some of these points for you. On the horizontal axis is the X variable. The left hand side is X of negative 240 and the right hand side is the X of positive 240. So for the X dimension, we have to keep the numbers, the random numbers, in between negative 240 and positive 240. Dragging this randomization script into the X position and updating the range of randomization variables. I do the same thing with Y, but if you notice on the screen, the maximum and minimum values for Y are positive and negative 180. And this is just a small example for how powerful scripting can be, and automation. On our previous time making asteroids, I manually made the stars by tapping on the screen to add in the stars, but that took a while. Now, within just a few lines of code, we can make something that will generate this work for us. The star generator script reads like this. When the flag is clicked, meaning when we start the project, we're going to erase everything, and then I'm going to increase the repetition to 50 times, and then I want the star to stamp itself. First, I want to make a duplicate of my star, a black duplicate of it, so that you guys will be able to see how it stamps itself all over the XY grid. And here you can see the stars that are stamped and spread out along the 4 quadrants of the backdrop. I didn't think that was enough stars, so I'm going to increase the repetition to 100. So now when we try it with 100 repetitions of generating a star in a random spot, we have a much more filled out starscape. So now that we did our examples, all we have to do is switch our backdrop and our stars back to their originally intended colors. But before we do that, why don't we make a fun example by spreading smiles all over our screen. Let's add a smiley face as one of our costumes to stamp all over the screen. Okay, and now time to test it out. Well, doesn't that just look happy? Okay, so now that we've done a fun test and a regular test of the concept for generating stars, let's go back to our original intention of making white stars on a black backdrop. Okay, so we switch the backdrop back to black and the stars back to white. There's our original star, and time to start it up and see some stars spawn all over our screen. That looks pretty good. All the stars look uniform and we didn't have to break our screen by tapping the heck out of it. So now that we have a backdrop with stars, we need a spaceship. I'm using the square tool to draw thin rectangles, and I'm going to adjust the color and use those as the walls of the spaceship. If you notice on the bottom of the rectangle there's a little squiggly arrow thing, and I'm going to use that to rotate the rectangle so that I can line them up to make a top half of a triangle. I selected the first rectangle, copied and pasted it, and then I'm going to put them together at the top. Next I'm going to make some smaller rectangles and then fit them at the bottom to make a bottom of the spaceship. This is going to be good enough for the prototype for now. Take a look at our Starfleet looking kind of insignia right here, and using the vector mode we can scale up and down the size. Next it's time to add some basic movement to the spaceship. So this first module is going to be for our turning and our acceleration. When the green flag is clicked, we want this to be forever applicable. If we're pressing the right arrow, we want the ship to rotate to the right or clockwise. The logic will work similarly for the other side. If the left arrow is pressed, then we want the ship to rotate counterclockwise. And we want to remember, as we're building this program, we want to be testing all along the way so that we know what's working and what's not working. I'm duplicating the last bit of script so that I can insert the mechanism for acceleration. So whenever we're pressing the space key, we're going to move forward. But which way is forward? I'm going to go into my costume for the spaceship and orient it towards the right. Time for the first test flight. Okay, here I am clicking the green flag. There's our stars generating. I can turn and I move in the direction that I intend to, which is pretty nice. I'm going to speed up this last little bit over here, but there's one problem with my controls in this space game, which is that if you see, I can't fly past the edges. In Asteroid, if you fly past the edges, you come out the other side. I also want to set up a starting location for my spaceship when I start the program. Next up, we're going to program the script so that you can wrap around to the other side of the screen. This is going to be a parallel script running at the same time as you are controlling your player. I'm going to be using the same control gates for the movement. When the green flag is clicked, meaning when the project is operational, I always, forever, want to have these conditions apply. The job of the operators over here is to look at the X position of the spaceship, and if it's more than 240 on the X-axis, I just want to tell it to change itself to a negative 240 so it can come out the other side, all other variables staying the same. Vice versa, if the X is less than negative 240, I want it to come out the other side as a positive 240. Okay, time to add all of these scripts into the control blocks. When the X position is greater than 240, set X to negative 240. And then we need to switch out the blocks for the Y position. And we need to update the range to be positive 180 to negative 180. So the effect of all of these control gates over here is that whenever we fly off this side of the screen in any direction, we appear on the opposite side of the screen. Time to test it out. Can we fly to the other side? Yes! Up, left, up again, right, up, works fine, down, works fine. This is the second iteration of making a spaceship game with kids called Asteroids. Thanks for watching, and be sure to check out Ethan and Leon's version of this video to see what their understanding of block programming is. See you guys next time!